Okay, in this problem we are asked to create graphs that are, the first one, part C here, it says that it needs to be discrete but not a function. And then we're going to create a graph here that's continuous but not a function. So both of them cannot be functions. So let's make sure we know what not a function means, since they both need to be not a function. So not a function means that every x is not going to have only one y. So there exists some x that will not have just one y. All it takes is one. If we're using the vertical line test, it means it fails the vertical line test. There exists at least one vertical line that, if you think of it going through the graph, it crosses the graph at more than one point. So again, to be a function, every x has only one y. Well, we don't want it to be a function, so every x does not have only one y. There will be at least one that has more than one output, one y value. So let's go through some possible answers. So again, there may be more than one correct answer. So let's also make sure we know what discrete means. So discrete, to review that, means the points are not connected. So we have to create a graph where the points aren't connected and every x does not have only one y. So, for example, that would be an example of discrete. The points aren't connected, and it's not a function because if I draw a vertical line right here through -4, -4, right here at -4, this is x is -4, has a point here and it has a point here. So then every x, when x is -4, it doesn't have one y. It has a y here, up here, this y value, -5, and it has this y value right here. So this would be a great answer. Let's look at another possibility. Here's another example. That graph would be discrete, the points aren't connected, and it is not a function because when x is -2, it has a y that it has a point here, a point here, a point here, and a point here. It has more than one y value. So if we look at the ordered pairs for these 4 points here, the definition of a function is every x should have one y, but when x is -2, it has this y value, has this y value, this y value, this y value. That's why it is not a function. Let's look at another possibility. Okay, that's another example. That is discrete and it's not a function. Even though when I draw a vertical line here, it only touches once, but I can see a spot here where if I draw a vertical line, it has 1, 2, 3, 4 different y values there. So this is not a function because when x is 2, it has multiple y values. Here's another example. Looks like a rectangle, but it's not connected because it has to be discrete, not connected. But it is not a function because if I draw a vertical line here at -1, it has 2 y values. So this is not a function and it is discrete. Okay, here's another example. Kind of looks like a triangle here. This is not a function because if I draw a vertical line here, it's good. It's fine, it has 1 y value. But I see several spots that if I draw a vertical line, it touches this graph twice there. If I draw a vertical line here, it touches it multiple times. Here, 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 here. So it is not a function and it is discrete. Okay, let's go ahead and move on to continuous but not a function. So let's review what continuous means. So continuous here means that the points are connected. So we need to draw a graph where the points are connected and it cannot be a function. So every x cannot have one y, it has to fail the vertical line test. So let's go ahead and do that. Okay, so continuous and it's not a function. A circle is an example. If I draw a vertical line here, touches the graph twice. If I draw a vertical line here, it touches the graph twice. So therefore it's not a function, and it's continuous because the circle, on a circle, all the points are connected. So you got to imagine that on the circle there's an infinite amount of points all the way around it, and they're all connected. So it is continuous and not a function. Let's look at another example. Okay, another example would be like that. All the points are connected, so it is continuous, but it's not a function. If I draw a vertical line right here through 2, 2 has a point here at 2, -2, and it has a point up here at, it looks like 2, 4. So every x doesn't have one y, it has 2 y values. Okay, there's another example. It's continuous, everything's connected, and it is not a function. If I draw a vertical line through, it touches more than once. If I draw a vertical line here, it touches only once, but I see a line where it doesn't, so automatically it's not a function. All right, let's go ahead and move on to the explaining part. Okay, so we're asked to explain why it's not a function. Well, we know to be a function, every x has to have one y, so we're going to say every x does not have only one y. And then if you want to be even more specific and detailed for me, you could take a look at your graph. So let's say your graph was this one here. And you could say every x doesn't have one y, and you could say, for example, when x is 1, so right here when it's 1, it has 2 y values. It has 2 y values. And I could even go further and say it has 2 y values, 2 and -2. So right here there's a point at 1, 2, and there's a point here at 1, -2. So because when x is 1, it has 2 different y values, that is why it's not a function for this particular graph. So I can go to my explanation here, and if I had that as my graph, I could add this to my problem. I could say every x does not have only one y, and then I could put even more detailed answer. For example, when x is 1, it has 2 y values, 2 and -2. Okay, another great example of a response. Instead of saying every x does not have only one y, instead of x, because what if it's not x in the problem? You could put every input does not have only one, instead of y, maybe it's a different variable, output. And then you could be even more detailed and say, for example, when x is 1, it only has 2 y values. It has 2 y values. Okay? Another response, if we want to use the vertical line test, we could say it fails the vertical line test, there is at least one vertical line that crosses the graph at more than one point. And then you could also, so if let's say you were using the vertical line test on this graph here, let's say you had this, you could also show me, like, look, hey, there's a vertical line right here that touches it twice, and you could, show me, look at that.